Hello, it's Keith here. Now, I know it's a bit odd for me to start playing a game. I don't usually play games on this channel, but there's a point to this. I want you to take a look at this game level. Take a look at the sprites on the screen and the colours in them and the background. Now, you'll notice that the sprites are using 4 colours and the background is using a different 4 colours. And you see the background colours have changed, but the sprite colours are still the same. Now, the other things I want you to notice is that this is apparently running in mode 0, the 16 colour mode that's 160 by 120. And you can tell that's 160 by 200, sorry, and you can tell that because of the resolution of the pixels. So where are the missing 8 colours, and why are they only using 8 of the colours? Well, let's just stop this game and do a different one. And if you look, we've got our main character, and that seems to be made up of 4 colours. And these enemies also seem to be the suspiciously same 4 colours, but the background is a different 4 colours. So, and again, we're in mode 0 here with these blocky pixels here. So once again, it looks a bit odd. It kind of looks like they're limited to using the same 4 colours for the foreground and the same and a set of 4 colours for the foreground. So they've got these 2 different coloured sets, and again, where are the other 8 colours? They seem to be completely missing. Well, if you've looked at the title at the top of this topic, maybe you've worked it out. But what they're doing is they're splitting the 16 colours, that's 4 bits per pixel, into 2 pairs of 2 bits, and that's effectively giving them 2 4-colour layers. And because they've got 2 separate layers, they can wipe the foreground out and recreate it without affecting the background. So that gives them a way of having 2 layers that can be changed independently without having to buffer the data that's in the background layer. Now, I know that's a little bit confusing, but we're going to actually look at some code to do this. But what I need you to think of is the bits that make up a pixel on the screen. Now, obviously, a byte on the screen has 2 pixels contained within it, but we're just going to look at 1 pixel independently because effectively they'll both work the same. Now, 1 pixel will be made up of 8 bits. Now, if we imagine the top 2 bits as being 1-bit plain and the bottom 2 bits being 1-bit plain, you would effectively see that colours 0 to 3 would be setting the bottom layer as colour 0, 1, 2 or 3. If you look at these bits here, that would be a 3 here. Now, if the top 2 bits are the top layer, then when these become 1, that would be colour 1, that would be colour 2, and that would be colour 3. Now, of course, these all would have this top set to 1, 2 or 3. Now, depending on the bottom 2 bits, these other colours, 4, 5, 6 and 7 for example, these would have to be the same colour as the top layer. Effectively what we're doing is we're splitting the bits into 2 sets, and we're setting the colours, giving one of those layers the priority over the other. So in this example, I've used the bottom 2 bits as the background layer. So colours 0, 1, 2 and 3 would be visible. But then the other bits, the top 2 bits, are the foreground layer. So anytime the top 2 bits are set, they would take priority over the background layer. And so what we do to achieve this is we set all of these colours to be the same colour, all of these colours to be the same colour, and all of these colours to be the same colour. And that's why the background is always the same. We'd have to have a shared background colour, of course, but that's why we've got an apparent 4-colour palette for the foreground and a 4-colour palette for the background, and that's why 8 colours are missing. So there we go. So that's the theory of what we're going to be doing. So it's really quite straightforward, really. We've just got to split our bits up and write some code to work with them. And as I say, if you look at it in this sense, where you can see the separation here, and you look at the top 2 bits being the foreground layer and the bottom 2 bits being the background, I think that's going to make the most easy way of understanding it. Now, unfortunately, the layout of the bits within the byte on the CPC are a little bit odd, to say the least. So the left pixel of the pair in the byte is made up of bits 1, 3, 5 and 7, and the right pixel is made up of 2, 4 and 6. I have no idea why that is. Now, based on our rules here, we're going to be using these bits and these bits for layer 2 and these bits for layer 1. Obviously, we're going to still be using 2 pixels, but you don't really need to understand that for today's example. Now, let's get up our winamp here. Okay, so what we've got here is a nice little example that we can use to test this out. So let's just fire it up first and let's just see it actually working. So if I do call 1200 here, now this is what we're creating here. Let me just pause it a second. So effectively what I've done here is I've defined the background layer as these four kind of orange-red colours, and the foreground layer as the sort of proper chibico colours with the purple hair and the white skin and the kind of cyan shoes here. So effectively, when our foreground layer passes over our background layer, the foreground layer appears in front. But if I just unpause it, when this sprite goes over this other foreground layer version, it deletes it. You see, this is the point. Because we're working on these two separate layers now, a foreground object over a background object will not affect the background object, but a background object drawn over a background object will delete the background object, or a foreground object drawn over a foreground object will delete the foreground object. So I'm in no way redrawing the background to allow for that layering effect. It's the code itself doing that, and we're going to look at that code today and understand how it achieves that. Okay, so let's have a look. Now, the code's quite long and a little bit complex, but we'll go over it in bits. So firstly, we're setting our screen mode here. This is only going to work in screen mode 0. And we're defining our palette here. We've got a few variety of palettes because we're going to have some fun later. We can actually make an effect where we use 3D glasses, the old Red-Cyan 3D glasses, and I've always been a big fan of those, so we're going to have a play with that later. But for now, we're just using our regular palette. Our regular palette is down here somewhere, maybe. Here's our palette, and as I said before, as we looked at in our sample here, the first 4 colours are the background colours, and then the remaining 12 colours are repetitions of 3 colours that will define the foreground layer. So we would set these all together, and if we don't, then when the 2 layers overlap, there will be weird colour effects, and that's how we do our 3D glasses effect. Okay. So that's our palette. We're just defining that here. We're just looping around here doing that. We're not going to go into that. We're just setting each colour as required. And then what we're doing is we're drawing some test sprites. So we've got 2 commands. Show layer 1 draws to layer 1 and show layer 2 which draws to layer 2. So we've got our 2 commands here. And then what we're doing here is we're defining 2 possible options. There's the regular option, which is what you just saw, or there's a bounce option. And this is really for the 3D glasses effect. So if I just compile this version, now this version just bounces the foreground layer around the background layer, just like that. Not too exciting really. So we'll see that bounce option in there. But so effectively what we're doing is we're setting a start position in D here, a Y position in HL, which will keep the same, and we are loading in our test sprite, and we're running this animate layer function here. We're then pausing. We're then clearing that sprite with a blank sprite, which is just literally a large set of zeros here, just to wipe out the sprite. And then we're just checking our Y position and changing our movement direction if required. We're then altering our X position and we're repeating. Now, the important thing is to notice that in this code, there's no kind of backing up of the background layer data. There's nothing to do that. All we've got is the data for the sprite and the data for the clearing of the sprite. And as I say, they're 2 separate layers, and the code that draws the sprite is dealing with those layers. So it's that drawing code we're going to want to have a look at. So here's show layer 1. Now this is based on my super simple series sprite drawing routine. So we're just getting our position here, and we are in this point we're actually drawing the pixels to the screen. So the bit that's doing all of the work of the 2 layers is here. Now what we're doing is this is the layer 1 version. So we are having to keep the bits of layer 2 from the current pixel in memory, and we're doing that with this AND command here. We're just loading in the mask for the pixels we want to keep. We're keeping those pixels and we're storing that back. So we're using the value in HL in screen memory as the backup for the pixels we want to keep. Then we need to get the pixels we want to put on top of that of our sprite. So we're just masking out, removing the pixels that would actually destroy the background. We need this to be a 4-color sprite, so just in case it's not, we're masking that here. And if you look here, the layer 1 pixels we need are 7, 6 and 3 and 2, and you can see that's why we're using these here. And of course the mask for the kept pixels is the opposite here. So we've masked off our pixels we want to keep, we've masked off our pixels we want from the sprite, and we OR in the sprite to the background and save the background. And that's it. That's all that we need to do. And that will keep the background, draw the layer on top, and that's it. Now there's the alternate version, that's the show layer 1 version. The show layer 2 version, almost the same. The mask here is opposite because this time we want to keep layer 1. And then we are just needing to bit shift the sprite data by 2 pixels, because if you look here, the mask was here, but now it needs to be here. And that's because this time we're drawing to layer 2. So we need to shift this bit to here. And we just do the same. We just keep the bits from the other layer that we want here, and then we OR in the new bits here, and that will do it for us. So these commands as a pair are allowing us to draw these second layers. There's 2 versions for the 2 different sprites, and to be honest, they're both almost identical. And that's really all there is to it. It's an interesting idea. I know it's not particularly popular because it's effectively wasting 4 colours and you've got the chunky sprites and things. But if you're looking to effect a foreground and a background layer, and you don't want to have to worry about redrawing things and caching bits of the background and what have you, this is an easy way, and it can give a much better solution than using XOR sprites which corrupt the background. So I think it's a bit of fun, and it's something you might want to try. And for me, growing up with these machines, I'd never noticed. I used to love Bubble Bobble, and I never noticed that it had that 4 colour limitation. I just didn't think about it at all. So it was certainly good enough for me growing up with Bubble Bobble. I was perfectly happy with it. So as I say, I think it's something that's worth you taking a look at, possibly if you're looking to do some simple graphics and you just don't want to have 2 screen buffers and things. So if we just disable our regular palette and use our Red-Cyan palette now, and we compile this, and if we now do call 1200, if you've got some 3D glasses, and I have some here, you should now see the Chibico character bouncing into the foreground and background in and out of the screen as the sprite moves over the other layer. And this is because if you look at it, we've got 1 layer as red and 1 layer as cyan, and the overlapping colours are now shades of white. And if I just find the palette data here, you can see that. So these are our white colours here. You can see them repeated here, here and here. And that's how we can effect a 3D glasses effect, by effectively making the coloured layers semi-transparent instead of being solid filled. And this is for Red-Cyan glasses, but if you have other glasses, if you have the magenta green glasses, which tend to give a very good 3D effect, then that will be supported by this palette. And if you've got the so-called colour code 3D yellow-blue glasses, then you can use that palette there, but the 3D effect isn't very strong on those. I don't think that works so well. So there we go. I mean, it's kind of a complex concept in a way. As I say, totally blew by me when I was using these machines when I was young, but fascinating, I think, and a bit of fun. So if that's something you want to try out, please download today's source code and, give it a go. Hope you found this interesting. Thanks a lot for watching today, and goodbye. If you enjoyed today's video, please check out my new YouTube channel known as Chibi Ackerman's Live. This is going to be a live streaming channel, and it's going to be some more casual content. It will be me streaming some of my programming sessions, me playing games and chatting along. I'm going to try and really do a lot of technical content in there, try and explain things as I'm playing games, talking about the hardware or while I'm programming. And also I'm going to try and interact with the chat a lot. So if you really enjoyed today's lesson, then maybe you want more content, and that will give it you. Equally, if you didn't enjoy today's lesson, if it was too hard for you, if you found it confusing, and you want something a bit lighter hearted, then it might be interesting to you as well. Though I guess you've probably already clicked off if you didn't enjoy it, because 95% of my viewers give up after about 2 minutes. But either way, thanks for watching, and goodbye.